Hi Nicole, I'm going to make two movies. The first one will be the MLE with the normals, and then I'll do the Poisson in the second one. So the MLE with the normal, you're going to have x1, x2, up through xn. Those are the, whoa, sorry about that. Go away. See if I can make that go away. It won't. Sorry. Those are the actual random variables themselves. If you want to think about the observed values, you're going to have x1 equals little x1, x2 equals little x2, and so on. So the random variables are the capital letters, the observed values are the lowercase letters. Okay? So let's think about the distribution, and it would look something like this. Let's just look at x1, and that would be this. Okay? And in your definition, it should say that these are IID, and what that means is they're independent and identically distributed. And that just means that all those x1s through xn's have the same mean mu and the same sigma squared. And there's no covariance. The independent part means there's no covariance, which is a big help. And then the identically distributed goes with the mean mu and the sigma squared. Okay, now let's take a look at the maximum likelihood estimator. So this stuff is just warm up. Now I want to get the likelihood, and that's actually the joint distribution. So you're going to have the product of all these. So you'll have this of all these babies. This is very hard to do. I hope you appreciate all the effort I'm going to. I'm teasing. If I didn't want to do it, I wouldn't actually. And a nicer way of writing this is like so, to the n over 2, e to the minus 1/2 sigma squared, and then a summation of EI minus mu, the quantity squared. All right, that's the likelihood function. Now, most of the time, you see, we want to get the maximum of that. Most of the time, you're better off to work with the log function. So let's look at the log function. And what I'm going to do, oops, the log of that, is pull this down. So I'm going to have n over 2, and that's going to be, let's make sure I do this right, of minus n over 2 of natural log of 2 pi minus n over 2, why is this being so bad today? N over 2, stop doing that. Getting little stars of log of sigma squared. And then when you take the log of the e function, you get minus 1 over 2 sigma and that big old function. Okay? Is that right? Let's look. That's right. Okay? So we have two parameters we have to look at. We have to look at mean mu, and we have to look at sigma squared. Let's look at mean mu first of all. We want to maximize it, so we'll take the derivative. We're going to take a partial with respect to mean mu first of all. And if we look at the first two terms, there's no mean mu in either of them. So we're going to look at that last term and differentiate with respect to mean mu. So I'm going to have the minus 1/2 minus 1/2 sigma squared sitting out in the front. I bring the 2 from here. I have a minus 1 from inside the function itself. And then I have the summation of xi minus mu. Okay, so let's see what's going to happen. The 2's, the 2's are going to cancel. The negative signs will cancel. And I will have the summation of the xi minus mu. All right, let's move on to the next slide. Nice clean. And we're going to take that. You're going to have a